these are the answers to page 25. Check through your answers real quick. We're going to go over problems. So make sure you follow along. We do have a quiz. I'm going to talk about the quiz here in a few minutes. If you missed number 22, there might be a problem just like 22 on the quiz. If you missed it, don't be a chicken. Make sure you ask. All right? If you missed problem 40, make sure you ask. Make sure you figure out how to do it before this quiz.
Did you count my paper? Because I have the wrong paper. I had my paper from 8/22. The 22nd. This is the right one.
I'll try to give you a 0.
Oh, will you fix it?
Not now. You're trying to mess with me. Make me walk around the classroom twice. You can see I don't do much walking. You can tell by my physique.
Did I really get a 0?
You're so gullible.
I'm gonna
Shut up.
I'm gonna pay closer attention from now on with you though.
The ceiling's orange. She's like, what?
Well, I didn't realize I had this paper out.
Start over here.
They're congruent.
So what do you know about all 4 sides if it's a square?
There you go.
They're equal, they're congruent. So do we actually have to use the distance formula to find all 4 of them? No, what can we do?
She's at 4.
Find one side, the length of one side, and then do what with that number?
Multiply it by 4.
Multiply it times 4, very good. Multiply it times 4, so pick me a side.
C and D.
CD, so segment CD, we're going to find this. I think that was these 2 points, right? We use the distance formula. Remember the distance formula? Looks like that, right? That's the bare skeleton of it. X's go here, Y's go here. What are our X's this time?
Negative 1, 0.
Negative 1, 0. Everybody knows, again, X first, Y, right?
Yeah.
Make sure X is your first coordinate, Y is your second one. What's our Y coordinates this time?
2 negative 2.
Be careful with your signs. I had somebody earlier today on this quiz came up and asked me a question. Of course, I wouldn't answer it, but they asked me, hey, I'm sticking in this negative 2 over here. Does that mean I'm adding 2, or does that mean I'm still subtracting 2, or what do I do there? You got a double negative there, so what do you do?
Add.
Don't change the sign. The sign in the original formula is always a minus sign. The only time you're going to change it is if you're minusing a negative. What's negative 1 minus 0? Negative 1, 4. Anybody lost so far? That makes sense to everybody so far? Negative 1 squared,
1.
4 squared, 1 plus 16.
17.
Looking over here at this list, 17 a perfect square number?
No.
No. What are you going to need on this quiz? I told you this last time. Calculator. If you don't have one, today and today only, everybody take a good look. You see this box? Albert's pretty box, right? Look at it. A long, long time today, because you will never, ever, ever see it again the rest of this year. All right? Because I will loan you a calculator today, then by the next time I have you in class next week and we need one, well, actually I have you tomorrow, but when we need the calculator again, you better have one, otherwise you will be out of luck. All right? Does everybody understand that?
Yeah.
Square root of 17, somebody's got a calculator, help me out, what is it?
12.
4.12?
Yeah.
So we'll just say 4.1, make it easy. 4.1. Is that our answer?
No, you times by 4.
That's how long this side is. Well, if this side's 4.1, what's this side over here?
4.1.
This side?
4.1.
This side?
4.1.
Now, I'm not going to go through all that. So we take 4.1 times 4,
16.4.
because we want the whole perimeter, and we get 16.4. Now, somebody else earlier today said, well, I got 16.5.
Well, you just rounded in.
Right. If you take your calculator, and I'll know that, I won't mark that wrong. If you take your calculator, the smart thing to do on a problem like this would be to get right to here and say, all right, the square root of 17 equals, and it's in my calculator. The next step I know I'm going to do is multiply by 4. Do I need to erase this out of my calculator and punch everything back in? No, I just hit times 4. And it gives me 16.49, which would round off to 16.5. So if you left the numbers in your calculator, it gives you a little more exact answer, and you don't have to punch so many buttons. Next question.
Number 26.
26. It says use distance formula to find the length of this segment. Somebody read me those coordinates so I don't have to keep trying to strain my eyes that I aren't even. 2, 3.
And 5, 7.
So we're using the same formula, distance formula, right? Somebody probably wants to see a midpoint formula. Make sure everybody remembers that here in a minute, right? Before we take this quiz. What's my x coordinates this time?
2 and 5.
2 and 5. Do I have to put 2 and 5 in that order?
No.
What would be easier?
5, 2.
That way they can confuse you with the negatives. You don't have to mess with them. How about over here?
7, 3.
7, 3. Make it easier on yourself if you can. Unlike the slope formula that you learned last year, with distance formula, midpoint formula, when you switch those around, it makes absolutely no difference. What is 5 minus 2? 3. I'm going to go ahead and make it even a little easier. What's 3 squared?
9.
7 minus 3? 4 squared. 9 plus 16?
25. And it's a square.
That's a perfect square number, isn't it? So how long is that segment? 5 units long. Whatever the units have to be. Everybody, as we went down through this, we had 3 here and 4 there. Ended up with 5 down here. Remember those numbers. Later on in the year, extremely helpful. 3, 4, 5. It's going to be something special.
4, 5, 6.
And no, 3, 4, 5 works. Not.
Just 3, 4, 5.
Other questions? 44? That's the hard one, isn't it? Problem 44. Somebody read me 44 real quick. I don't have to try to look at it.
Find the coordinates of the missing endpoint given that S is in the midpoint of R2.
So we're looking for an endpoint this time. All right? All the other problems, we were given the 2 endpoints. We're looking for the midpoint or the distance, the length of it. This time, they're telling us the midpoint and one of the endpoints, and we got to find this other one out here. You're going to be able to use the formula the exact same as normal?
No.
No, it's going to have to be like backwards, and I'm going to show you that. Go ahead, keep going.
T. Wait, that's.
Just tell me the 2 the points that they tell you.
2 and 8.
2, 8. So out 2, up 8.
And negative 2, 2.
Negative 2,
2.
2, somewhere about in there. What is it? Is it this one here is the midpoint, right?
Yeah.
All right, so that's your midpoint. I'm going to put an arrow. So our segment actually runs there. Does it run on up this way?
No.
Runs down. Oops, probably went a little too far. A little crazy. Something about like that, right? So the coordinates we're looking for should end up down here somewhere. Probably not quite as far as mine because I went a little nuts. But we're going to use that midpoint formula. Remember, it's the x is added together divided by 2, y is added together divided by 2, and that should equal the x coordinate of the midpoint and the y coordinate of the midpoint. Normally, we don't have this part over here because that just ends up being our answer. This time they gave us the coordinates of the midpoint. What were the coordinates of the midpoint? What'd you tell me? 2 or negative 2, 2? So that's over here. They told us one of the x coordinates. What were the coordinates for this point up here? Was it 2, 8? Is that right?
Yeah.
So one of the x's was 2, the y was 8. Do we know the other x coordinate? Do we know this x coordinate down here? So what do you put in place of something when you don't know it?
Right.
What do you put in the place of this one over here when you don't know it?
Y.
A y. So that's what the formula looks like. Now what we got to do is say this part right here, 2 plus x divided by 2, should equal what? Should equal that right there, right? Should equal the x coordinate of the midpoint. And then we solve it. I know Mr. Griffin or Mr. Harrison did a spectacular job teaching you how to solve these last year. Even though it's got a fraction in it, they made it so you weren't scared of fractions anymore, right? What do you do to get rid of this 2? Do the opposite. Multiply both sides by 2. Those cancel. 2 plus x equals
4 or negative 4.
negative 4. How do we get x by itself?
Subtract 2.
Subtract 2. And x equals 6.
X equals negative 6. So what's the x coordinate of this point over here?
Negative 6.
Negative 6. Are we finished?
No.
We got to do the same thing for the y. Somebody tell me how to set up the equation for the y. What do I write down?
8 plus y.
8 plus y
Oh, that's it.
divided by 2 equals
Negative 6. Or negative 2. Or 2.
multiply both sides by 2. I ran out of space over there. Can you see that's a 2? 8 plus y, these cancel out. What's 2 times 2?
4.
Now what?
Subtract 8.
What's y equal?
Negative 8.
That's the ordered pair of that other endpoint that they didn't tell us.
Somehow I did that one, but I didn't do the other one.
Now, this is probably the hardest thing that they could have done as far as that, everything on that page, okay? Telling you a midpoint and one of the endpoints, and you have to find the other because you had to use the formula backwards. Somebody, does anybody want to see one of the just regular midpoint ones? Find me one. Because that one was hard. I didn't put anything like that on the quiz. We'll just use the formula straight up on the quiz for now.
40.
40. Read me the coordinates.
4, 2. And 8, negative 6.
And we want to find the midpoint, right? How do you know if you're trying to find the midpoint or if you're trying to find the distance? They tell you.
Yes.
They'll say, how long is this segment? That means distance. They'll say, find the midpoint. That means use the midpoint formula. So in this case, we use the midpoint formula. What's our x coordinates here?
4, 8.
Y coordinates?
2, negative 6.
Please watch your signs. 4 plus 8 is what?
12.
12 divided by 2? That's half our answer. 2 plus negative 6?
Negative 4.
Negative 4 divided by 2?
Negative 2.
Don't do this. I see a lot of people doing this. 6 plus negative 2 is 4. And then writing 4 down as the answer. No, 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 no. They asked you for a midpoint. You're finding an actual point. You got 2 separate answers there. An x coordinate and a y coordinate. When you're doing distance, then it all goes together and just gives you one number out as your answer. Other questions? I need to do that a bunch while you're sitting there. I know you're awake, man. I'll keep you awake. Other questions? Some other things. Let's do let's see here. Q is between D and P. How would I draw that?
Q in the middle of, well, in
What do I draw?
Line.
A line?
No,
the segment,
Segment?
And then,
DP,
and then label DP.
So this is D on the end,
Yeah.
P on this end,
yeah, and then somewhere in between you
And
put
then
Q.
somewhere in between you put Q.
Q. Now they're going to tell you other information, right? They'll say DQ is, maybe they tell you DQ is X.
You label.
You label it that way. Alright, Paige, does all that make sense? You sure? Don't lie to me if it doesn't. Sorta? Mostly? Label this one, maybe they tell you this is 2x minus 4. And then probably, can we do anything with just that information? No, we need something else, don't we? What else would they need to tell us?
The whole length.
Probably the whole length. Maybe they tell us this whole thing is 52. What equation could I set up from that? X plus 2x minus 4 equals 52. Then you solve that. Now you solve it and you find x. Is that probably your answer?
Yeah, well, no.
They probably are going to ask you to find one of the segments. So please make sure, read the question carefully and know what they're asking you for. What if they told you to, what if they said find that? What's that telling you to find? The length of segment DQ, which in this case happens to be the same as x, just because I was lazy and didn't feel like putting a coefficient with the x. How about, oops, hold on. How do you find the precision number for that?
Find the smallest unit.
Smallest unit?
1 foot.
1 foot? What do you do with that?
Times by 0.5.
Times it by a half. 0.5 if it's the metric
Yeah.
system, right? What is 1 times a half?
6 inches.
6 inches or 1/2 foot or 6 inches. In that case, I would accept either one of those answers. That's your answer. You don't have to do anything else. That's your precision number. It's saying, we measured this, Anna measured this, and she told us it was 38 feet. All right? Well, from what we know that it's probably not exactly right, because you can't ever get anything exactly right, but we're saying we're for sure that Anna is within 6 inches, either too high or 6 inches too low. So she's in that range. Now that range, 6 inches down and 6 inches up is a whole foot. That's not a real precise measurement, right? So she could be off by this much, and so that's not real precise. But this is your precision number. This is that number you're looking for. How would I explain it using the word between?
Oh, you subtract
Oh,
38
it's
minus
between-
a half.
yeah.
38 minus a half, which is what?
37.
37 and a half feet.
So then 38.
Add a half, 38 and a half feet. So we know that the actual measurement's between 37 and a half feet and 38 and a half feet. On the quiz, I didn't ask you to explain it, I just wanted the precision number. Any other questions?
And that's what I was gonna ask, you like,
What?
you answered what I was gonna ask.
I'm like the world's greatest teacher because I can read your mind, right?
Yeah.
Albert, will you do me a favor and flip the light on over there? If you need a calculator, you can get up and get one real quietly. Please make sure they get back. Please make sure they get back into the box. Bring one from here on out. I will not bite your head off today, but after today I will, and you'll be out of luck. Oh, they stole them all. You got one more? Better start moving quicker, Noah. You must not have very many brothers and sisters.
I got a whole bunch.
You do?
Yeah.
Then you should know.
I'm the oldest.
Mom calls
Down
dinner.
the hall.
Mom calls dinner. You better get your butt out there. Or you out of luck.
Yep.
On this quiz, you can use your notes. You can use your book. You can use your calculator. Can't use your neighbor.
Why not? I just like a calculator.
So Anna knows you and Caleb over here, all right? You got about 7 minutes to do it. So don't waste time.
I'm screwed then.
You'll be all right. You're screwed if you're wasting this 10 seconds telling me you're screwed.
Well, that's
Let's go. The other thing I'll say, any math class, I don't know what kind of math teachers you had in the past, should you show your work?
Yes.
Yes. Each one of these problems, I think there's like one of them that's only worth 1 point. The rest of them are worth more than 1 point. You show your work. You start the problem off right. Looks like you know what you're doing. You just make some careless mistake. You get partial credit. Mr. Alexander, when you get to him, he's the exact same way. Show your work on, it was supposed to be my timer. Oh, is that you? Man. You're having a bad day today, aren't you? You get finished, you can bring your quiz up there right here on the blue chair. Continue to work, babe. About your computers. You cannot use your computer as a calculator. So if you've got that in your mind, know that that will not be allowed. So find a calculator. Problem number 1. You're going to draw that segment, right? Go ahead and keep working. Problem number 1, you're going to draw that segment, label it, all that. Problem number 2, precision. We just went over one of those. Number 3 says find the length of segment RT, and it gives you ordered pairs. What formula are you going to use on that? Distance formula for number 3. Number 4 says find the coordinates of the midpoint. What formula are you going to use on that? Midpoint formula. Number 5, what kind of person is going to leave number 5 blank?
No one.
I hope.
Stupid people.
I hope no one. Circle the answer on number 5. Make sure I can tell which answer you have on number 5. And don't waste too much time on one problem. That got everybody's quiz.
Oh,
About 1 more minute.
I can't usually do time tests.
On the quiz, find DF. Is DF a line or a segment there?
Segment.
Segment. How do you know that?
Because
Because
it's two
there's
capital
only two.
letters.
Yeah, and it can't be a line, because they continuous.
There's no logo, no symbol.
Give me more. How do you know it's a segment, not a line?
It says it's
You're,
between two
because you
points.
are finding the length of it. You're finding the length of it. You can't. Can you find the length of a line?
No.
We're gonna have fun in this class with one of you. Because one of these days I'm gonna draw a line on the board. I'm just gonna come in and we'll start class this way. I'll draw a line on the board and I'll hand the yardstick to Wade and I'll say, Wade, go up and measure that line for me. And Wade will come up here and he'll be measuring the line. 22 inches.
Are you serious?
I'll say no. 21.5 inches. No. I won't even be paying attention to what answers he's giving me, of course.
Because they'll all be wrong.
22.25 inches. No. And he'll be up here all day. It's got to be something around there. And what am I going to tell him after about 5 minutes of me laughing?
Can't measure.
You can't measure a line, so you shouldn't even have tried. All right? So we know it's got to be a segment. We're going to draw this. We draw this segment. Everybody see that red?
Yeah.
What points go on the end of the segment?
Yeah.
What is it?
E and F.
EF.
Oh.
And we know D is between those two, so D's in here somewhere. They tell us that ED is 6x, so I label that from here to there, 6x. Not a negative 6x,
But it says
my pen.
minus 4.
Oh, minus 4, sorry, I missed that part. Can't hardly read that, can you? DF from here,
3x
3x minus 5. Is that right, or is that plus 5?
minus. Or,
Was it
No,
plus?
it's not.
I think it was plus on the thing, wasn't
I
it?
can't see.
Yeah, it
It's
was.
supposed to be plus, you can't hardly see it on there. And then they tell us the whole thing is 46. What are you gonna do with these two parts?
Adam.
Add them and they should equal,
46.
so 6x minus 4 plus 3x plus 5 should equal 46. Collect like terms, what's 6x and 3x give us? Negative 4 and 5
1. Eight.
plus 1, positive 1, right?
Yeah.
46, subtract 1 on both sides. I'm going to do this sort of quick after this. 45, divide by 9, what's x? Is that our answer?
No.
What they ask us to
Plug it
find?
in.
Plug it into 3x plus 5.
They ask us to find DF, so we got to go back here and plug it in. 3 times 5 is
15.
plus 5.
20.
So the answer should have been 20.
Yeah.
Find the precision, 24 meters. What's the smallest unit?
1 meter.
1 meter, take that times what? 1/2 or 0.5. We use 0.5 since we're in the metric system. What's 1 times 0.5? That's our answer. Precision's that easy. That's the precision number. Find RT. So again, what are we finding?
Distance.
Distance, length of RT, and we're using distance formula. Same thing every time. This part is the skeleton part of it. Every single time. What's the x coordinates for these two?
2, negative 2. Or negative 2.
-2, -3. Y coordinates?
5, negative 6.
Good. 5, -6. Both of these we can change the signs there, right?
Yeah.
Mr. Harrison used to do some boom bang. I don't think he does that anymore when he changed the signs on those. But what's -2 plus 3? So we got square root of 1, or I'm sorry, 1 squared. What's 5 plus 6? 11 squared. What is 1 squared? 1. 11 squared.
120.
121. 121 plus 1.
122.
122. Even if you didn't have a calculator, could you use this chart up here?
Yeah. It's close to 1.
And you say, man, that's awful close to 121. Well, what's the square root of 121?
11.
11. It's real close to that, right? So would you guess it's like 11.7? No, it's probably a lot closer than that. And this answer actually, does everybody know what that symbol means? About approximately. I think it come up to be 11.0. Now a lot of you, I probably won't mark it wrong this time, but I bet a lot of people put 11. Is that the correct answer for what they told us to do?
No.
What they tell us to do? Round to the nearest tenth. We look back up here at our precision. You look at that measurement that you just gave somebody, they're going to think you rounded off to the nearest whole number. Did you?
No.
No. Is this number right here more precise than that measurement there?
Yeah.
So that's why we need that 0. Even though it doesn't really mean anything, we need it because it's a figure that shows us, hey, we rounded off to the nearest tenth, not the nearest whole number. How about on this one, what do we use?
Midpoint.
What's the x coordinates this time?
3 negative
3, -3. Y coordinates?
negative 5, 6.
Everybody else other than Allison and Isaac know this, right? What's 3 plus -3?
0.
0. I'm going to go ahead and do this. What's 0 divided by 2?
0.
So that's the x coordinate. What's -5 plus 6? 1. 1 divided by 2? 1/2 or 0.5. That's our midpoint. Last one. How many planes are in that picture?
6.
Everybody in the whole class said 6?
Yeah, I said A.
Come on, somebody didn't say 6, did they? There's got to be somebody that didn't say 6. Don't be a chicken. 6 is wrong.
It could be
Thank
7
you.
1 or what?
What?
It's 5 or 6.
All right. How'd you know that? You
Oh,
looked at
yeah.
my key or something, didn't you?
No, I did not.
Thank you, Lane.
I did not. 'Cause the
How come
bottom
I'm
is
saying
the
it
last
could be
one.
5 or 6?
Because
the
the
bottom.
bottom plane.
I don't know about the bottom. You look at that and you probably think it doesn't have a what? A top.
Or top.
I would think it wouldn't have a top, right? Because it sort of looks like maybe a horse trough or something like that, and you'd think, well, you're not going to put a top on it because then you can't get water or food or whatever else in it. So you're probably thinking it doesn't have a top. Well, if it doesn't have a top, how many planes are there? 5. If you considered that it did have a top, then it'd be 6. Now,
How can you tell?
exactly. That's why I said either answer. But there is a way to tell that I didn't know till today, so I learned something today. A student told me this. If you look right here, what do you notice about that segment back behind there?
Don't even
It's
see.
dotted. Usually when something's dotted, that means what?
It's going through.
Cut it out.
Or
It's hidden, right? No, not cut it out. That's in your little second grade books. Cut along the dotted line.
yeah, it's not.
That means it's hidden, right?
Which means it would be.
Well, is that part right? If that part right there is hidden,
Means there's a top.
that means there is a top
So
on
that means
this.
the answer is 6.
So the answer would have had to been 6, but I'll still accept either answer. Because I never, until today, I've used this picture many, many times over the last 7, 8 years. I've never noticed that, and somebody said, Mr. Eversole, but that part up there is dotted. So that's telling you that there is a top on it because that would be hidden. All right, please make sure you put your blanks out here. You could fill in the first blank, knowledge before right now. What do you know about angle measures? What we're going to cover, measuring and classifying angles. When I ask you to classify an angle, that's something completely different than naming an angle. Some teacher in the past must have taught everybody when you name an angle, give me a name of an angle. Obtuse, acute, that's all wrong. All right? That's how you classify an angle, not how you name it. Okay? You name it with letters, just like we name lines, segments, rays, all this other stuff that we're going to learn about. You name it with letters. You classify it by saying it's in a certain group. Obtuse, acute, so on and so on. So we're going to learn that. Again, you could fill in the first blank, how much knowledge you have. You might think that, oh, I know everything about angles because some teacher taught you. And then you might figure out here in a little while that, oh, maybe I didn't know as much because Mr. Eversole's telling me something completely different now. Teachers didn't lie to you in the past, they just didn't tell you the whole truth. It's like when you were in first grade, did you know about negative numbers? No. Were there still negative numbers even though you didn't know about them yet? Yeah, they were still around in the world, but your teacher just didn't tell you. Alright, because they didn't figure that Michael could handle it at that point. They told you what you need to know to get you to a certain point. Congruent angles. What's going to be true about two angles if they're congruent?
They're the same.
They have the same measures. Very good. They have the same measures. So if I tell you an angle is 70 degrees, and some other angle is congruent to it, what do you know about that other angle?
70
It's got to be
degrees.
70 degrees. Very good. All right. So that's what we're going to cover today. Again, put your blanks out there to reflect. We'll get back to that towards the end of class. All right, write these down, skip a space or so, maybe a couple lines in between each one. We're going to go over them sort of quickly. Anybody have any idea what a degree actually is? I'm going to give you a definition that's going to be wrong. All right, but it's going to be a definition that you can use. Anybody know what a degree actually does?
That's like a measurement of a mass or something.
Sort of. Gets you a job. That's a different kind of degree. All right, what the definition we're going to use, degree is a unit used to measure angles. Now, I've told you all year long that when you hear a word in geometry class, no matter where you hear that word at outside of geometry class, does it mean the same thing? Yes.
What about temperature?
All right, and that's what I was getting ready to say. That's why I said that this is a terrible definition, because that's not really true. What a degree actually is, if I hold my arms like this, a degree measures the amount of turn. You see how my arms sort of turning? So if we actually had a real clock up there, not the stupid digital ones like we have all the time now, or digital thermometers and all that stuff, that's what it measures. Long time ago, thermometers, you might look out at your grandma's house on the tree, and there's an old thermometer out there, and it looks like this. Anybody ever seen those thermometers? Got the old hand on it? And guess what they do? They turn.
They measure.
And guess when it got to be 90 degrees, guess how much of a turn?
90 degrees.
90 degrees. What we consider 90 degrees as far as an angle goes. Right? So a degree, when we're measuring an angle, if this is one side of my angle, and this is the other, what we're actually measuring is how much of a turn is that angle making. All right? Now, we got away from this because we started using mercury and whatever else in the thermometers, and they went up and down instead of turning anymore. But that's what a degree is the amount of a turn. So when you're watching racing on Sunday, and they talk about the turns on the track, how many degrees they are and stuff, that's where it comes from, the amount of the turn, how much something's turning. But we're going to use it just to measure an angle. Hopefully most of you know, if you see something like this, what's that little symbol up there? Degree symbol. Hopefully I don't have to go back over that. Array. Array looks like this. When you name array, use 2 letters and use the array symbol. Any of my geniuses in here got any guess as to what the array symbol is?
A line with a dot and arrow.
What if what's the symbol for a line?
A line.
How have I said it all year long? I know it's only been 2 weeks, but a little line. What's the symbol for a segment?
A little ray.
A little
Ray.
A little segment. Now, Isaac,
Okay.
what's the symbol for a ray?
A little ray.
A little ray. So it looks something like that.
Little rare.
Come on, you stupid thing. We use two letters, little ray. Now, a ray is a little bit different than lines and segments, because with a line, we could pick any 2 points, and we use those 2 letters to name it, right? Didn't matter. Segment, same thing, and we could switch the orders around. Ray, you can't do that, all right? Because this ray has a certain direction that it's going in. Well, you got to show that direction by how you name it. I use that little symbol. Anybody have a guess how you're going to name this ray? Say it again.
QP.
Q, P. Why do we start with Q?
Because the first.
That's where you start, and then having the P on the other end tells us that that ray goes out in that direction forever. All right? What if I did something like this? Name me a ray in that picture.
MS.
ST.
I heard MS. Well, if I name that ray that way,
No, it's not right.
that's a ray in this picture.
How?
Because if I name that ray, where's that telling me to start at?
Oh, it's the other.
Start at M, and which way do I go?
Towards that.
Now, somebody else, Allison was saying, no, that's not right. Maybe she was going to say ray MT.
And ST.
Would ray MT be a different ray?
Yeah.
No.
MT, is that a different ray than MS?
No, it starts
No.
at the same spot.
Now, would ray ST be a different ray?
Yeah,
Yes.
because it starts at a different place.
Wait, then you can do TN too, right?
Sit down and do a project here in a minute. Sounds
You do
like
too.
not a plan.
Did you do TN?
Now, could you do what?
TN.
Yeah.
I'm doing the
Ray TM. What's that telling you?
To go the opposite way.
You're going the opposite direction. You're starting at T and you're going out that direction. So rays have direction. Lines, did a line have a direction?
No.
No. Did a segment have a certain direction? No. Opposite rays. Any guesses to what opposite rays are?
It's on the left.
Maybe it's different. Maybe
So would, if I had this ray, would that be an opposite ray for it?
no.
What would it have to
That's
make?
beyond the
Make a,
180-degree turn.
So it'd be like the one that you just drew.
it would be a
Line.
line, all right? So if I have something like this,
Yeah, you just drew that above it too.
no, I didn't. That was a completely different line.
Come on now.
Look, you can see them both. See that line?
Yeah.
See that line? They're two different lines. They're not the same line. If they were the same line, I would have done this. I just drew right, same spot again. Two different lines. Name me two rays in this picture.
AC.
Give me a different one. I don't like that one.
ABC.
I heard BC. BC and, I ran out of space. BC and what other ray are opposite rays? Look at BC. Goes out this way.
BA.
Ray BA would be the other one. So ray BC and ray BA are opposite. Sorry that that's so sloppy. I got too close to the side of the board. They're opposite rays to each other. Again, anytime you have opposite rays, what are they going to form?
Line.
A line. An angle. When you have opposite rays also, they shared a starting point, right? They have the same starting point. Two opposite rays have that same starting point, and they go out in exact opposite directions of each other. An angle. Angle looks like this. What do you still have in that picture?
A little ray.
Just one ray?
Two rays.
You got two rays. And those two rays again have the same starting point, but do they go out in opposite directions?
No.
Not necessarily, all right? So, same starting point. Same starting point. But they don't have to go out in opposite directions. They can just go out in two different directions. All right, write these down. Draw this picture. We got an angle here. We're going to go through this real quickly because we only got 15 minutes left. Caleb's wasted all our time.
Come on, Campbell.
Look at this picture. Everybody have any idea where the vertex of this angle is?
T.
T.
So point T is the vertex. That's where the two rays both start at. All right? How about the sides? The sides of an angle are always going to be two what?
Points.
Two
Great.
rays. Thank you. Name me one of the rays that's the side of this angle.
TB.
TB.
Ray TB. Make sure you're naming it with the symbol and the two letters. And what's the other ray?
TA.
TA.
Does that make sense to everybody? Miss Otherson, does that make sense? Make sure you don't let Allison and Isaac push you out of this class, all right? Make sure,
Why is it always hard?
I won't answer.
because
that.
you guys are the ones yelling all the time.
Okay, let's
I'm
be
not,
quiet.
I'm not saying that it's a bad thing. I'm just saying that, I need to make sure that everybody,
Last year we were in the same algebra class and
We
you
did this
did
again.
Mr. Griffin get annoyed with you?
A little
No.
bit.
Yeah.
A little bit.
They disagree, don't they? Where do you think the interior of this angle is?
Inside the two rays.
All this stuff, interior of the angle. Where do you think the exterior is at?
Outside side.
Outside.
We're supposed to be quiet.
All this stuff out here, exterior. If I'm dealing with this rectangle, which one do we care about more? The interior of the rectangle or the exterior of the rectangle?
Interior.
The interior. So here, which one do you think we're going to deal with more often?
Interior.
Interior. We're going to deal with interior a whole lot more than we deal with the exterior. How about some point, let's say some point right here. Is that on the interior or exterior of that angle?
Interior.
Oh, interior.
Why is it on the
The
interior?
rays are going out.
The what continues?
Ray.
The rays, thank you. Please, as you write these down, I know Alexis thinks she knows the definitions. She might know two of these definitions. She doesn't know the other two.
Are you serious?
Good.
Well, you're
So
wrong.
watch my TV, you'll be a lot better in a minute.
No, I'm just not gonna answer.
Because she's going to give me the wrong answer.
No, I know it right. Are you serious?
A right angle, what's a right angle?
90-degree angle.
There. It took Isaac a second. He was sort of going chicken out
Is that
there for a
right?
second too. Has a measure of 90 degrees. Let's skip the two middle ones. A straight angle, what's it?
180-degree angle.
Measure exactly 180 degrees. What's another name for a straight angle?
A line.
A line. Now, difference. Can you measure a line?
No.
No.
You can
So if
measure-
you want, but you can measure a straight
Straight
angle. So if I draw this and I say, give me that measure,
You can't.
you should say 180 degrees is the only way I can measure it, right? You can't measure it as a line, but you can measure it as an angle. Acute angle.
Below 90 degrees.
That's wrong.
Well, I just wanted to answer one of them.
See, she didn't care. that
That's
she-
why I didn't answer it, because I knew it was wrong.
Why is it wrong?
It's not.
Yeah, it is.
No. Like 40 degrees is an
It's
acute.
between 0 degrees and 90 degrees.
So it has a measure between 0 degrees and 90 degrees. Why? No, it's not the same thing. Your teacher told you what Allison's over here arguing. It's less than 90. Are there other numbers less than 90 other than what I've listed right there?
Yes.
Give me some numbers that are less than 90 that don't include that.
Negative 25.
Negative 25, negative whatever. There are negative angles. If I'm doing this, look, if this is my positive angle, what do you think this would be?
Negative.
A negative angle. And there are things in the world where we use negative angles. Now, once you know that, now Allison, she's probably smart enough that she can figure this out. What's an obtuse angle?
Between, would it be 91 or 90 and 180?
Between 90 and 180.
Yeah, but
How
that's
come you don't say
180.
91? When you say it's between 90 and 180, what's it include?
91.
Does it include 90 degrees?
Oh, 90.
No, when it said
91.
when I say it's between,
Let's say it's
if
not
I
90.
if I say name somebody between me and Paige,
Mine.
can you say my name? No, because I'm not between.
But you can't say Paige's name.
So here, exactly. So here, when we say it's between 90 and 180, is the 90-degree angle going to work?
I got it.
No. Now, if you did what Allison wanted to do and say start at 91, you forgot a whole bunch of angles in there between 90 and 91. Is there some angle in the world that's got a measure of 90.3?
Yeah.
Yeah, and you just left them out. They're nothing now.
Wow.
All right?
I'm sorry.
So we got those four. These are the ways to classify angles. When you hear to classify the angle, this is what you do. You give it one of those names. When you name it, it's something completely different. Classify one of those four names. All right, what I want you to do, we only got like 9 minutes left, but we got time to get started, and we got to get started. What I need you to do, in an orderly fashion, but quickly, come up, grab a piece of scrap paper, a protractor, a compass, and a ruler.
Right there. Too bad, Mike.
You learn a whole bunch, Tom.
No, I mean, I gotta get done for my stuff.
You know, right?